first equation of motion. So for this we will draw first xy axis like you can see on the screen, and since the object is moving with a constant uniform acceleration and has some initial velocity, so the graph will look like this. Now from this graph, first I'll put up what's there on my y-axis, that is the velocity, and since we know that the unit of velocity is meter per second, I'll put that also. On the x-axis, I have time. Now we can see that there is some initial velocity of the object. Let this point be A. This point is A. Now since there is an initial velocity and this one is the final velocity, so I'll put that as B. From B, I'll draw perpendiculars from point B to the x-axis, that is my time axis, and I'll go like this. Similarly, I'll make perpendiculars from B on my y-axis, that is the velocity axis. After I have done this, I'll label both the parts. So this part is C and this is E. After labeling it, I'll draw another perpendicular from A and it will bisect this line at point, let's label this as D. Now from what I have calculated, we can say that the initial velocity of the object is U, that is this one, is U at point A, and then it increases to V at point B. So the whole part, this one is V. The change from A to B occurs in time t, and this time t is from this point to this point. This is t. So from the graph I can conclude that OA, now OADC, this whole area is a rectangle. This whole area is a rectangle, right? So from this I can say that OA equals CD, which is equals U. Similarly, OC equals AD, which equals T. And the third thing that I can conclude from this is I have my U, I have my T. Now last thing is that BC is equal to V, right? I hope this much is clear to you. Now we'll move on to the derivation part. Since we have drawn AD perpendicular to BC and ADOC is a rectangle, so I can say that this BC is the sum of this BD and DC. Where my BD we do not know, DC is U and BC we know is V, right? So let's do the calculation part. So from the graph we can observe that what we have from the graph is that BC is equal to BD plus DC, right? Now what I'll do is this DC is equal to OA, right? As you can see here also from the graph, this DC and this OA is same, so I can put this equation as is equal to BD plus DC is replaced by OA, right? From this equation I can find that BD, which I do not know, is equal to BC minus OA. I'll replace the values. From here I know that BC is equal to V and my OA is equal to U. This equation I have found out, right? Now we already know what is acceleration. So acceleration is rate of change of velocity. So whenever the rate comes, we put time in the denominator and it is the rate of change of velocity. So we will have change of velocity. Or we have also studied that the slope gives the acceleration. The velocity slope of a velocity time graph gives us the acceleration, right? So from this A equals, now the slope will be the y-axis minus x-axis. So it will be A equals BD divided by AD. I can easily replace this AD with OC, right? Since ADOC is a rectangle. Now from this I will get A equals BD divided by OC. Now what was the value of BD? From our previous equation, BD equals V minus U, right? So I will replace this BD with V minus U, and OC, if you remember, was my time and it was T. So OC is time. Putting all of this in equation, I'll get A equals V minus U divided by T. Right? I hope you landed here. We have just substituted the values, nothing else. Now from this, the equation that I have in my hand is A equals V minus U divided by T. Now doing the crisscross, I have 1 beneath this. So what I'll do is, I'll move this T in the numerator and this one in this numerator, right? So I will have AT is equal to V minus U, or I can say V minus U is equal to AT. This is the equation. This is my first equation of motion, which is also known as the velocity-time relation. Yes, so I can summarize this as V minus U is equal to AT, or I can also say that V is equal to U plus AT. Any one is correct. Here V is my final velocity, U is my initial velocity, A is my acceleration, and T is the time taken. I hope this is clear to you. If you have any doubt, please do mention in the comment section. Next we will be deriving the equation for position time relation. Bye.